isobutyl. This fragment is isobutyl. So we have two isobutyls attached to aluminium and one hydrogen. This structure is dibal H. So if you have RCN, that means any nitride dibal H in the first step. In the second step, you add water and you are going to get RCHO. Also, these reducing agent, they don't hinder the double bond. So if you have a double bond like this, and then you add dibal H, secondly H2O, you're going to get the same number of carbon atoms and CHO. Yes, Fahad, that is nitrides. First line में ये nitrides and esters can be reduced by mild reducing agent such as dibal H. Similarly, if you have esters, double bond O, OCH3, then again, first step is dibal H. Second step is water. Now till the carbonyl carbon, you will make the complete thing. Okay, and this carbonyl carbon will turn into CHO. Double bond O and hydrogen. So two carbon atoms. Here also two carbon atoms. So till carbonyl carbon, you are going to get all the carbon atoms, and then OCH3 will be not there. Write this down. After this, you all will write the fourth one. The fourth method of preparation. Abdurrahman, please take a screenshot if you have just joined. Third example is C double bond O. आप इसको खोल के लिखिएगा तो C double bond O आ जाएगा फहद. You just need 4 carbon atoms. 1, 2, 3, 4 carbon atoms. CHO को अगर आप खोल के लिखिएगा तो ये आएगा ना. Right, next. Etard reaction. Now please write. Alkyl benzenes are oxidized to benzaldehyde. Are oxidized to benzaldehydes with a solution of bromyl chloride with a solution of bromyl chloride in CCl4 or CS2. Both of these are solvent, these are not reagent. So for chromyl chloride, we need a non-polar solvent. That is why we use CCl4 or CS2. Right, next. A brown chromium complex is formed. Which is decomposed when by water, by water to give benzaldehyde. So if you have CS3, this is toluene. Methyl benzene is known as toluene. And then we add chromyl chloride. Formula of chromyl chloride is CrO2Cl2. CrO2Cl2. Now this will be in the presence of CS2 or CCl4. You can write CS2 or CCl4. Even if you don't write that solvent, that is okay. But you should understand that this is a solvent, not a reagent. This leads to formation of, it can't be the CS3. Now, I hope all of you understand. If I write the CH here, it doesn't matter. Okay? All of these, both of these structures are same only if I write CS3 here. You write CHO, CrCl2 and OH, CrCl2 and OH whole twice. This is a brown complex. On addition of water, it gives CHO. This is benzaldehyde. Now, it doesn't matter how big your alkyl chain length is. Even if you have CH2, CH3, and you react this in the presence of chromyl chloride, CrO2Cl2, in the presence of CS2. In the first step, in the second step, you add water. You're going to get benzaldehyde. So please remember this reagent whenever you have to form benzaldehyde. Whenever you have to form benzaldehyde from a benzene that is containing alkyl group. If there is any alkyl benzene, you just remember this particular reagent. Otherwise, there are two more methods for preparation of benzaldehyde from methyl benzene. From toluene, we can prepare benzaldehyde from two more methods. But please remember this method because this is having less number of reagents. The next one are having some multiple steps. Okay, and also one more thing is that if you are having a long alkyl chain length, then also it can reduce this to benzaldehyde. Then also it is going to rather oxidize it to benzaldehyde. Write the structures fast and then write using chromic oxide in acetic anhydride. It's going to be the fifth method of preparation. Using chromic oxide in acetic anhydride. Now, Etard reaction, I'm also telling you to remember because it is the name reaction. So when you remember Etard reaction, you also remember a name reaction. Then you also remember a reagent for the preparation of benzaldehyde, no matter how long the alkyl chain length is. Now, please see what happens. In this case, here also you're going to have methyl benzene. CS3. Here we use chromic oxide. Again, chromium-based oxidizing agent. This is also an oxidizing agent. We have CrO3. Now, this will be somewhere around 0 to 10 degrees Celsius. And acetic anhydride. Acetic anhydride is CS3CO. hold twice oxygen. Now, what is the structure for this? Oxygen, it should have two bonds. Now, both of these bonds are having C double bond O and C double bond O. So this is the CO part. And both of them are also having CS3 here and CS3. Okay, so this is acetic anhydride. Now, this first of all forms a chromium complex. The structure of chromium complex is CH, O, CO, CS3 hold twice. This is known as benzylidene. It's known as benzylidene diacetate. Now, on further treatment with water in the presence of H+, it gives benzaldehyde. Plus 2 moles of CS3COOH. So this acetic anhydride is converted to acetic acid. But this is my main product, that is benzaldehyde. Now, similar to this one is the sixth reaction. In sixth reaction, we use by side chain chlorination. In side chain chlorination, we take again methylbenzene, toluene. Now, since CH3, this is a sp3 hybridized. This is a sp3 hybridized carbon atom. That means it is going to give reactions of alkane. And hence we can do chlorination. Cl2 in the presence of H nu. If you remember in haloalkane halorine, we did the method of preparation of haloalkane. One of the method was halogenation or free radical halogenation of alkanes. The same reaction happens here, and we stop the reaction when we have two chlorines in the carbon atom. So here you have hydrogen and two chlorines. Now, this is a haloalkane, and this haloalkane is going to show typical reactions of haloalkane. Now, one of the typical reaction of haloalkane is when you treat this with water at some temperature, so around 373 Kelvin, then OH is going to replace both of these chlorines. So OH replaces both of these chlorines. Typical nucleophilic reaction of haloalkanes. So here you are going to get OH, and here also you are going to get OH. Now, when you have gem diol type of situation, when a carbon atom is connected to 2-hydroxy group, it is very unstable, and water molecule leaves from here. So water molecule leaves from here, and you are going to get CHO. And you are going to get benzaldehyde once again. So write this down. This is side chain chlorination. This reaction can be written as like this. But again, this gives a mixture of products, so it is not a very good method of preparation of benzaldehyde. This is in the first step. In the second step, we add water in the presence of heat, and you will get CHO. After this, you will write the seventh reaction. Gattermann-Koch reaction. In a Gattermann-Koch reaction, first of all, If you have seen any gutter, gutter will have a hole which is having handle of this shape, benzene ring. Then you should remember from KO, you will remember CO. And then the reagent HCl from HCl. Okay. Coach mein hi aapke paas you have HC. So from that you will remember HCl. In the presence of anhydrous AlCl3, this gives benzaldehyde. So Gattermann Koch reaction. Gattermann Koch reaction. Write the statement for this. When benzene is treated with carbon monoxide and HCl in the presence of anhydrous AlCl3, it gives benzaldehyde. Now all the methods of preparation of aldehyde only is completed. Then we have the next method of preparation of ketones only. C part, method of preparation of ketones only. In this, you will write the first one from acyl chlorides. Okay, so acyl chloride is a general acyl chloride is written as R C double bond O Cl. Now, when you react this with dialkyl cadmium, some different R dash, twice and CD. In this case, chlorine is replaced by the different alkyl group. So you are going to get R, C double bond O, and R dash. Okay. If you want to balance it, you can write 2 acyl chlorides, and this will be 2. Plus, you will get CdCl2. Okay, but you don't worry about the mechanism, or rather the stoichiometries here. If you have RCOCl and then it is reacted with dialkyl cadmium, you are going to get ketones. Now, how to prepare this dialkyl cadmium? This dialkyl cadmium is prepared by Grignard reagent. So let's suppose you have a Grignard reagent R dash MgX, and you react this with CdCl2, cadmium chloride. Now, in this case, what is going to happen? This R dash is again going to replace this chlorine Cl. So you will get what? You will get R dash whole twice CD plus you are going to get Mg XCl. Okay. Now, what is happening here? Please see, all of you guys. You will be given something like this in questions. R, or rather not R, let us write 1, 2, 3 carbon atoms, C double bond O and Cl. They will give you a number of reagents like this. First, they are going to give you, if you have CH3 whole twice CD, CS3 whole twice CD. If they have given you only this much, then it is fine. Then you are going to just replace the Cl with the alkyl group. So what is the alkyl group in the cadmium? It is CS3. So you will write 1, 2, 3 carbon atoms, C double bond O. Everything is same. Just instead of chlorine, you will write CS3. But if you have been given something like this, let us suppose you have 2 carbon atoms, and then there is Mg, and you have Br. First step, they are giving you CdCl2. Second step, they are giving you CS3, COCl. CS3 COCl has a structure of CS3 bonded to carbonyl carbon with a double bond oxygen and a chlorine atom. Okay, so यहाँ पे आपके पास product क्या होगा? In this case, your product will be the CS3CO will be as it is. CS3 C double bond is as it is. And then you will have how many carbon atoms? Whatever carbon atoms are present in the Grignard region. So how many carbon atoms are present? 2 carbon atoms. This is 1 carbon atom. This is another carbon atom. Okay, so here you are getting ethyl methyl ketone. Ethyl methyl ketone. So you have 2 alkyl groups in every ketone. In the case of acyl chloride, one of the alkyl group will be coming from the acyl chloride, and the other other alkyl group will be coming from the Grignard reagent originally. If not Grignard reagent, then the dialkyl cadmium. Okay, dialkyl cadmium. This dialkyl cadmium alkyl group is coming from the Grignard reagent. Okay, so please write this down. Here in the formation of product, you have to remember there are 2 alkyl groups. One of the alkyl group is coming from acyl chloride. The other alkyl group, it is coming from the Grignard reagent or dialkyl cadmium, whatever is present. Now write next. From nitriles using Grignard reagent. Now in this case, you have a nitrile. Let us suppose you have like this. R C triple bond N. Now in this nitrile, the carbon atom is connected to nitrogen via multiple bond. That is why it is going to have a very high electrophilicity, a very high delta positive charge here. And you will have R dash MgX. In this case, R dash, the alkyl group of Grignard reagent, is connected with magnesium, which is a very electron donating group because it is a metal. Metal has a tendency to give electrons. So this alkyl group will be having a delta negative charge. Now this alkyl group will attack on the nitrile like this, on the carbon atom. As soon as it attacks on the carbon atom will say, okay, nitrogen, I don't want one of your pi bond because R or the alkyl group is making a sigma bond with me. So first of all, I am going to get R C double bond N, R C double bond N, and this carbon atom will be having a bond with R dash. This nitrogen will be having further bond with MgBr. Now, once we add water to this, so addition of water will be like this. Okay, addition of water will be like this. You will have one more hydrogen here, I say. So you will get NH3. This carbon atom will get the oxygen, and the Mg is going to get the OH. So you will have R C double bond O R dash plus ammonia plus MgOHBr. MgOH by R. So what we are adding? We are adding here water. That's it. So the questions will be given to you like this. You will have CH3CN. Then first step, 2 carbon atoms, MgBr, Grignard reagent. Second step is water. Or they will give water, or they can also give you H3O plus. Now what you have to do, take both of the carbon atoms from nitrile like this. So you'll have CH3, and the nitrile carbon will get the C double bond O. Then the next alkyl group will be the alkyl group of Grignard reagent. So how many carbons? 1, 2 carbon atoms. So you write 1 carbon atom and 2 carbon atom like this. You don't have to worry about these byproducts. In organic chemistry, you just have to worry about the major product. For example, they can also give you CH3CN. The first step, they are going to be phenyl magnesium bromide. Second step, water. So here what you are going to do, here you are going to do CH3, C double bond O, and then you have the phenyl group. Whatever group is attached to the Grignard reagent, that is you are going to attach as the second alkyl group in the ketone.
So can you scroll down?
Scroll down. Done, everyone? Done, guys?
Yes, sir.
Right, next, Friedel-Crafts acylation of benzene. The third and the last method of preparation for ketones only. Friedel-Crafts acylation of benzene. Right here, aromatic ketones can be prepared by aromatic ketones can be prepared by Friedel-Crafts acylation. Friedel-Crafts acylation by treating aromatic hydrocarbon with acyl chloride. Acyl chloride is also known as acid chloride. So if you have somewhere acid chloride, it is the same thing. Acyl chloride in the presence of anhydrous AlCl3. Anhydrous AlCl3. So you have benzene ring, and here you have one acyl chloride such as CH3 C double bond OCl. Now, in the presence of AlCl3, so first of all, देखिए इसमें हम आपको बता देते हैं how to make the product. You start with CH3 C double bond O, and the next alkyl group will be the benzene. तो जो भी acyl chloride का CH3 C double bond हो, you write that first and then you write the benzene ring. Okay. So for example, if you have first of all, you will write 1, 2, 3 carbon atoms, C double bond O, and then the benzene ring. Here also same thing. You just remove the Cl. Cl को मत लिखिए. You have benzene ring, and then the carbonyl carbon. The rest of them will be another benzene ring from here. Okay. So first of all, you will write whatever acyl chloride part is, except the chlorine. You don't write the chlorine. Okay. And after that, you will add the benzene ring. No matter what the acyl chloride is, even if you have something like this. Now this benzene can have some other groups, but don't worry about it. You can have, let's suppose, C double bond O, Cl. So this complete fragment of acyl chloride and then attached to with benzene ring. Write this down. Try to write the products on your own. पहला example, second example तो देख लीजिए लिख के screen से. But for the next one, please write on your own. Try to write it on your own and then look at the screen. Okay. Right. Next, the method of preparation is complete for both aldehyde and ketones. Aldehydes only, ketones only. Next, we have the physical properties of aldehyde and ketones. Okay, tell me one thing. How many of you gave the test on Friday? Raise your hand. How many of you gave the test on Friday? Okay, Huzaifa, Jiva, Zad, and Zad. Okay, आप लोग ने तो नहीं था. आप लोग से बाद में बात करेंगे. Then those who have given the test, please tell me. At the end, there were many definitions. Those were not the part of question paper. आप लोग को समझ में आया था?
Yes.
कोई ऐसा है जिसने उसको भी लिख दिया, डेफिनेशंस भी लिख दिए हो पेपर में कि मार्क्स मिलेंगे? आपने? अब्दुल रहमान, वेरी नाइस. हु? एनीवन एल्स?
नो सर, नहीं लिखा.
नहीं लिखा आपने? अच्छा. मैमूना, आपने लिखा है? यस मैमूना, वेरी गुड. पेपर में था लेकिन ना, आई थिंक यू डिड नॉट सी द पेपर करेक्टली.
The one at the end.
हाँ, टुवर्ड्स द एंड.
like the assignment, something like that.
हाँ, या करेक्ट, उसको नहीं लिखना था।
Okay, okay. I didn't write. I didn't write.
हाँ, वेरी गुड। उन्होंने नहीं लिखा, उन्होंने इंस्ट्रक्शंस पढ़े थे। ठीक है। अच्छा, एक और चीज, लाइक एनीथिंग दैट यू वांट टू ऐड कि पेपर में होना चाहिए नहीं होना चाहिए, कुछ इंस्ट्रक्शन मिसिंग थे तो बताइए। हाँ, एनीवन? See, in this instruction, actually I saw some papers, they have written the complete definitions also. Some theoretical questions are given at the end of the chapter as assignments. Okay, so what I will do, खैर अभी तो आप लोगों को पता चल गया कि नहीं लिखना है, लेकिन कुछ बच्चे ऐसे होंगे जिन्होंने लास्ट पेपर नहीं दिया होगा, तो उनको पता नहीं है कि पेपर कैसा था। So I will add a section, जो वो पार्ट था ना डेफिनेशन वाला, उसमें ही I will add a line like this. These questions are not part of test. These are to be submitted as assignment later. ठीक है, इस तरह के कुछ इंस्ट्रक्शन I will write on top of those theoretical questions, because देखिए, and in the examination you will only get numericals, you will get conceptual questions, and you will get Y type of questions. ठीक है, and ऐसा होगा तो ऐसा क्यों होगा, right? And also like consequence type of question, कि अगर हम ये करेंगे तो क्या चेंज आने वाला है, क्या चेंज नहीं आने वाला, बट डेफिनेशंस टाइप के क्वेश्चंस नहीं दिए जाएंगे। डेफिनेशंस वो लिस्ट होगा, वहां से आप एग्जाम से पहले बस पढ़ के चले जाइएगा। ओके, क्योंकि वो याद करने की चीज है, उसमें कुछ अप्लाई नहीं करना है आपको। कंसेप्ट का ये है कि कंसेप्ट अगर क्लियर है देन यू कैन राइट द आंसर्स। हाँ, गिव रीजन टाइप ऑफ क्वेश्चन, वाई टाइप ऑफ क्वेश्चन वही गिव रीजन टाइप ऑफ क्वेश्चन। एंड एप्लीकेशन के भी सवाल होंगे ना, कि अगर हम ये चेंज कर रहे हैं तो क्या, लाइक व्हाट इज द कॉन्सिक्वेंस ऑफ दिस चेंज, इस टाइप के भी सवाल हो गए। ओके, डेफिनेशन बिल्कुल नहीं होगा, मेरे पेपर में तो नहीं होगा, हाँ सर, ठीक है, डेफिनेशन विल नॉट बी देयर। एंड अब ऐसा नहीं बोल सकते कि थ्योरेटिकल क्वेश्चन नहीं होंगे, है ना। थ्योरेटिकल क्वेश्चन इन द सेंस की थ्योरेटिकल क्वेश्चन तो वाई टाइप ऑफ क्वेश्चन, रीजन टाइप ऑफ क्वेश्चन सारे थ्योरेटिकल ही होते हैं, तो ऑब्वियसली थ्योरेटिकल टाइप ऑफ क्वेश्चन होंगे, लेकिन डेफिनेशंस वाले नहीं होंगे, याद करने वाला नहीं होगा, एप्लीकेशन वाला होगा। ओके, राइट, नेक्स्ट, physical properties. Now in physical properties you will write the first point, aldehyde and ketones are soluble in water as they form hydrogen bond with water. So if you have C double bond O, okay, so if both of these groups are alkyl, then it will be ketone. One of the groups is alkyl, it will be aldehyde. And water has a structure of like this, and you have another aldehyde or ketone, whatever you have taken. Now both of these can form hydrogen bond like this. Since this hydrogen is having a high delta positive charge, is also having a high delta positive charge, and we have the lone pair of oxygen atom that is going to give some electron density towards the hydrogen. So it is kind of a hydrogen bond here. Why hydrogen bond is formed between, देखिए आपके पास ना H को delta positive होना ही होना है. Okay, H should be always delta positive. If H is not attached to any electronegative element, then hydrogen bond cannot be formed. That is why if you look at ketone and aldehyde, see aldehyde के केस में hydrogen है, ठीक है, but this hydrogen is not able to form a hydrogen bond with the oxygen atom. Why? Because this hydrogen is not very delta positive, because it is attached to carbon. Carbon is not as electronegative as oxygen. Carbon is not as electronegative as oxygen atom as we have in this case, water के case में. So aldehyde के अपने आप में नहीं होते hydrogen bond. Similarly, ketones also do not have any hydrogen bond within themselves. But when we add it in water, they form hydrogen bond. And related to this was a question in your solution chapter also, with respect to acetone and chloroform. Acetone on it itself does not have any hydrogen bond. Similarly, chloroform on its own does not have any hydrogen bond. But when you mix them, they form a hydrogen bond, and that is why they are azeotropes. Okay. So here also you can see water. खैर यहाँ तो water के पास hydrogen bond होता है, But acid, the aldehyde and ketone, they on and own within themselves, they do not have any hydrogen bond, but they form hydrogen bond with water. Now, the alkyl groups, these are non-polar. That is why these are unfavorable for the solubility. They are unfavorable for the solubility. And if you are going to increase something which is unfavorable for the solubility, if you're going to increase the number of alkyl chain, and alkyl chains are going to decrease the solubility. Okay, so in total, we can say on increasing the alkyl chain length, the solubility decreases. Why? Because alkyl chain length, these are non-polar. Please write solubility of aldehyde and ketones. Solubility of aldehyde and ketones decreases rapidly with increase in length of alkyl chain. With increase in length of alkyl chain. Now, right next regarding the boiling point. Boiling point of aldehyde and ketones. Boiling point of aldehyde and ketones are higher than non-polar hydrocarbons and weakly polar ethers. And weakly polar ethers. Hydrocarbons mean alkane, alkyne, benzenes, all of these are hydrocarbons and weakly polar ethers. So because aldehydes and ketones, these are strongly polar molecules, they are having higher boiling point than ethers and hydrocarbons. But if I compare this to alcohol, right next. However, due to absence of hydrogen bond within aldehyde and ketones, their boiling point is lower than corresponding alcohol. Corresponding alcohols. Okay. So first of all, the highest boiling point will be of that compound which contains hydrogen bond. Then the one which is polar. Then the one which is weakly polar. And then the non-polars. Write a question. Arrange the following. In increasing order of boiling point. The first molecule is an aldehyde. Second molecule is alcohol. The third molecule is ether. And the fourth molecule is normal alkene. Okay. So first of all, whenever you get a question like this, you classify the classes of compounds. So this is aldehyde. This is alcohol. This is ether. And this is alkene. Then you need to identify what type of intermolecular force of attraction is present. In aldehyde, these are polar. Alcohol are hydrogen bonded. Ethers are weakly polar. And alkane is non-polar. Once you have got this, it is very easy to write the order. So here you will have second one with the most because it is hydrogen bonding, then the polar, that is the first one, then the weakly polar, that is the third one, and then the non-polar, that is the fourth. Please write this down. Right, next, chemical properties. Of aldehyde and ketones. Now, in this, the first reaction that we are going to look is the addition of ammonia and ammonia derivative. Now, addition of ammonia and ammonia derivative, there is a complete list of 7 reactions. All of those 7 reactions are very similar. Okay, all of those 7 reactions are very similar in the formation of product. So I will give you the mechanism. In all the mechanism is not required. We'll give you the mechanism of ammonia, but you have to understand similar reaction happens for all of these cases. Okay, and I will also give you on how to make the products, for ammonia and then the ammonia derivatives also. So please write the number 1, addition of ammonia and ammonia derivatives. Please write this with me, addition of ammonia and ammonia derivatives. Now, I hope you have written this. Now, please don't write anything, just listen. We have carbonyl compounds, aldehyde and ketones. So aldehyde and ketones will be attached with some 2 groups. If both the groups are alkyl, then it is ketone. If one of the group is alkyl, the other is hydrogen, then it is going to be aldehyde. C double bond O. Then we have NH3. Now, when you see NH3 like this, there is something missing. The missing item here is the lone pair. Now, since we have lone pair, and this carbon atom is what? Delta positive, because it is attached with oxygen atom with a double bond. Now, this nitrogen atom is going to attack on the carbon atom like this. Okay. Now, nitrogen atom, it attacks on carbon. So nitrogen is what? Electron rich. It is attacking on carbon atom, making a bond with carbon atom. Carbon atom already has 4 bonds. That is why it will say to oxygen, please take your pi bond. Please take your pi electrons. And we are going to get carbon atom, the 2 bonds, whatever were added, whatever was present, that are present as it is. There is no change in those things. You have NH3 here. Now, since nitrogen is bonded with 3 hydrogen atoms, it will gain a positive charge. No, nitrogen atom is, this complete thing is a nucleophile. Okay? Nucleophile जो होते हैं, compounds होते हैं. And it is a nucleophile because of the lone pair. Lone pair nucleophile नहीं होता है, ये compound nucleophile है. But why it is nucleophile? Then you will say because of the lone pair electrons. It will get a positive charge because it has donated electrons to carbon atom and formed a bond. Here we have the oxygen atom, which is oxygen. Now it is going to have 3 lone pairs. Oxygen in general, with a 2 bond, it has 2 lone pairs. With 1 bond, it is going to have 3 lone pairs and a negative charge. And since nitrogen atom is bonded with hydrogen, these hydrogen will have delta positive charge because nitrogen is electronegative, delta positive and delta positive and delta positive. Oxygen will say to hydrogen, come, I have a negative charge, give me the hydrogen. And what is going to happen? The hydrogen bond with nitrogen is going to go back to nitrogen. So we'll have this thing is known as proton transfer. Okay, this is very common in organic chemistry. When we have 2 electronegative element very near to each other and they have hydrogen atoms, then there is always happening proton transfer. These are reversible reaction, but it is going to go towards this neutral form. So 2 groups as it is, nitrogen with 2 hydrogens now, and we have OH, and then we have OH. Now still this hydrogen is having delta positive, this is also having delta positive, and this oxygen will say that, okay, hydrogen, please come with me. And then the hydrogen is going to give the electrons to nitrogen once again. Now nitrogen is neutral, it will get the electron and get a negative charge. So we'll have carbon atom, the bond as it is. Here we have oxygen and a positive charge. Here we are having nitrogen and with 1 hydrogen, NH, and a negative charge. Since we can see that we have formed water molecule attached to carbon atom, oxygen will say, okay, carbon, tata, bye bye. I'm taking the electrons. Nitrogen say, okay, fine, take your electrons. I'm going to give the electrons to carbon atom and form a pi bond. It is going to form, see, whatever bond were attached, they are attached as it is, the 2 bonds, double bond, NH. Okay, so this complete reaction mechanism is just a sequence of attack of nucleophile on the carbonyl carbon. Then there is 1 proton transfer, then there is another proton transfer with the elimination of water. So what is removed from here? Water is removed from here. Now, in general, we can see whenever you get a ammonia or ammonia derivative, you will look at like this. The carbonyl carbon is the main thing, and you are going to have NH2. You will separate the H2 like this, and then nitrogen, and then hydrogen. Okay, so here you are going to get this water will be eliminated. Water is eliminated, and you get carbon, the 2 groups attached as it is, double bond N, and then hydrogen. Now in ammonia derivative, instead of hydrogen, you will have different groups. You can have OH, you can have some alkyl group R, you can have another NH2. Okay, so this hydrogen will be replaced. In general, for ammonia derivative, you will have this type of reaction, carbonyl carbon attached to 2 groups, double bond O plus H2, N, and N is attached to Z. So this Z is going to change. Z is going to change, but the reaction is going to be the same. You will remove water from here, and you are going to get carbonyl carbon with a double bond N and Z. Okay, so please write this down now. Important thing is this part, how to form the product. This is important. You are going to be asked about the product, not about the mechanism. Okay, so please write the complete thing with mechanism also, but please focus on how you are going to write the product. So carbonyl carbon and ammonia derivative, then first of all, you will give C double bond N. C double bond is will be there. C double bond N will be there, and then you are going to attach the Z. You have to look at the ammonia derivatives in the form of H2NZ. The Z in the case of ammonia was hydrogen atom. You will have amines. In that case, the Z is going to be alkyl group. Okay, so please write this down. Then we'll look at different things. Please let me know once you're done. Is there anyone who's still writing? Okay, Ahmed is writing. Is there anyone who is still writing? Right, next. Identify the Z in following. See, if you have NH3, आपको NH3 को सबसे पहले किस फॉर्म में लिखना है? You have H2 and then H. So what is the Z here? Tell me, guys. What is the Z in this case? देखिए, इससे कंपेयर कीजिए. Compare to this and tell me. हाँ, I did. तो आपको सारे में से क्या हटाना है? NH2 हटाना है सिर्फ, ठीक है? So you remove the NH2 and whatever is remaining is the H. Whatever is remaining is Z. Second. What else you can have? Now the last one, that is इसका हम बता दे रहे हैं. Here you have two NH2. ये वाला NH2 है. You have the NH2 that is directly bonded to carbonyl carbon. Then you have the NH2 that is bonded to NH. So this NH2 you will remove, and the rest of it is Z. So what is the Z here? It is NH C double bond O NH2. Okay, so please write all the Z, whatever you can see. I'm giving you guys 5 minutes. 5 सवाल है आपके पास। इसमें प्लीज 4th वन एंड 5th वन में प्लीज ध्यान से लिखिएगा, NH2 हटा के, अक्सर लोग मिस्टेक कर देते हैं। प्लीज राइट इट केयरफुली देन सेंड मी ऑन व्हाट्सएप। Yes, that very good, correct. Yes, Ahmed, that is correct. So once you identify the Z, it will be very easy for you to write down the products. Okay. So the most important thing is to identify the Z. Yeah, Ahmed, correct. Both of these are correct. Abdurrahman, looking at your answer. Okay, Abdurrahman, first one correct, second one correct, third one. ठीक है. Fourth one, NH, yeah, correct. Fifth one वाले में आपने Z नहीं बताया क्या है, but I can understand you have formatted it in H2 and Z manner, so R is going to be the, okay, yeah, correct. Correct, Abdurrahman. Jiva, looking at your answer now. Yeah, I think all of you guys are answering it correctly. Let me write the answers now. Please see. NH2, you remove the NH2, what is remaining? OH. Remove the NH2, what is remaining? NH2. Remove the NH2, what is remaining? NH. And then phenyl group. Phenyl को आप pH भी लिख सकते हैं. You have NH, and here you have the phenyl group with nitro at the second and the fourth position. And in this case, if you remove NH2, the R is going, sorry, the Z is going to be R. और 7 वाला तो हमने बता ही दिया था. Those who have not written, please write it down. Okay. Now in this, we'll write A, reaction with ammonia. Ammonia, NH3. What does it form? It forms imines. C double bond O, generic reaction I'm writing, C double bond O plus NH3. This is going to give you C double bond O and H. Specifically, if you have acetaldehyde CH3CHO plus NH3. Acha, all of these reactions, these are catalyzed by acid, so you can have H plus here. Okay, all of these reactions, these are catalyzed by acid. Then in this case, you will be having CH3 as it is, CH as it is, double bond N followed by H. If you have a ketone like this, sorry, double bond O, NH3. So C double bond N will be there always. Now what is the Z in this case? It is hydrogen. So this will be the product. Write with me B case. Reaction with amine. In reaction with amine, it forms substituted imine. Substituted imine is also known as Schiff's base, SCHI double F apostrophe S, Schiff's base. These names are important. Okay, they can directly ask you what is skiff space. So you'll write this is a substituted amine. Now in general, C double bond O plus NH2, some alkyl group R. In the product, you will have C double bond N. What is the Z in this case? It is R. So N bonded to Z. Specifically speaking, if you have CH3CHO plus NH2CH3, then in this case, we'll have CH3, CH, double bond N. The Z in this case is CH3. The alkyl group is the Z. If you have ketone, NH2CH3, the C double bond O will be replaced by C double bond N, followed by the alkyl group CH3. Try to make the products on your own. Please copy करने की आप कोशिश मत कीजिए यहाँ पे, ठीक है? ट्राई कीजिए कि खुद से आप लोग प्रोडक्ट लिखें. And if there is some mistake, doubts हो रहे हैं आपको, लेकिन लिख लीजिए एक बार, जो भी समझ में आ रहा है वो लिख लीजिए, and then look at the answer.
So H2 is released.
H2O will be released in all of these cases. Right, next. Third, C. Reaction with hydroxylamine, NH2OH. Right, it forms oxides. In general, C double bond O plus NH2OH or C double bond O, N bonded to OH. प्रोडक्ट खुद से लिख लीजिए आप इसका. Okay, write the products for this on your own. Double bond N, the Z is OH here, so double bond N and then OH. So structures याद रखिएगा, oxides, skiffs base, imine. What are these structures? They can directly ask you to write an example for imine, skiff base, oxide. Then you will have hydrazone, then you will have phenyl hydrazone, and so on. Right, next. D case. Hydrazine. Hydrazine is NH2NH2. C double bond O plus NH2NH2 is going to give you C double bond N will be there, bonded to NH2. Write the E case. Phenyl hydrazine. Forms phenyl hydrazone. C double bond O plus NH2, NH, phenyl ring. C double bond N, NH, then the phenyl ring. Right, next. Reaction with 2,4 dinitrophenylhydrazine. F. Reaction with 2,4 dinitro phenylhydrazine forms 2,4 dinitro phenylhydrazine. This 2,4 dinitrophenylhydrazone, it is orange red PPT. It is orange red PPT. So if you have C double bond O plus NH2 NH, NO2 in the fourth position and NO2 in the second position. This will give you C double bond O, sorry, C double bond N followed by NH. Phenyl group with the NO2 in the para and in the ortho position. Write a note. Write a note here, 2,4-DNP test is used for detection of carbonyl carbon. Or carbonyl compound, that is aldehyde and ketones. So if there is a compound that shows positive 2,4-DNP test, that means you have a compound, you added 2,4-dinitrophenylhydrazine and it gave orange or red PPT. That means that compound is either aldehyde or a ketone. That compound is either aldehyde or a ketone. Right, next, reaction with semi-carbazide. Is right, it forms semi-carbazone. Write the products. Right, next. Now, all of these were the reaction of ammonia and ammonia derivatives. Then we have other nucleophilic addition reaction. All of these were nucleophilic addition reaction in which nucleophile is attacking. All of their ammonia derivative, the ammonia has nitrogen, nitrogen has lone pair, and nitrogen attacks as a nucleophile. So here we have second reaction, that is nucleophilic addition, which is addition of hydrogen cyanide, HCN. Now, in this case, first of all, it forms cyanohydrin. And in this case, base is used as catalyst. Now please see, we have HCN plus OH negative from the base. So this will be attacked by OH negative. The OH negative will attack hydrogen. It is going to form CN negative plus H2O. Now the CN negative, it will attack the carbonyl carbon because it is delta positive, and CN negative will have negative charge on the carbon atom. So this attacks on the carbonyl carbon, and same thing happened. The carbonyl carbon gives the pi bond to oxygen, leading to formation of O negative, and this carbon atom gets a CN. Carbon atom, it gets a CN. Now, once this happens, we have the water molecule that is very available here. The water molecule, it will give the hydrogen to O negative, and you will get C, the groups attached as it is, OH and CN. This is CN, not CH. CN. This is cyanohydrin. ठीक है, तो यहाँ पे बहुत ही आसानी से you can write the product. You can say that the hydrogen of HCN gets attached to oxygen, CN gets attached to the carbon atom. So for example, if you have double bond O plus HCN, then you will be getting OH and CN. Similarly, if you have C double bond O and hydrogen here plus HCN, you will be getting the same things. Hydrogen here, the CH3 here. CN will be attached to carbon atom, and oxygen will get the OH. Double bond O plus HCN. So all of these are in the presence of base, OH negative, OH negative. But again, OH negative is just a catalyst. Even if you don't have OH negative, the reaction is still going to proceed. It will be slow, but it will proceed. Have OH, this carbon atom will get CN. After this, you are going to write addition of sodium hydrogen sulfide. Now, sodium hydrogen sulfide, in this case, you have C double bond O plus NaHSO3. Now from here we have Na plus and HSO3 negative. So in HSO3 negative, the negative charge will be on sulfur. Sulfur is going to attack on the carbon atom. So you are going to get the carbon atom as it is. You will get SO3H and ONA. Instead of O negative, 5-10 minutes more. Okay, here I will complete this nucleophilic addition, then we will be done. Okay, आप लोग की क्लास 2 घंटे की मान के चला कीजिए आप लोग, ठीक है। जनरलिटी इज ऑफ 1.5 hours, आधा घंटा हम लेके चलते हैं डाउट्स के लिए, बट जनरली डाउट्स नहीं होते हैं। ओके, सिलेबस भी कंप्लीट कराना अभी। So here you can see O negative and SO3H. Then there is a proton transfer. Oxygen will attack on the hydrogen atom, and you will get. But since this is kind of reversible, proton transfer, carbon atom with OH, and here you are getting SO3Na. So if you have CS3, CHO plus NaHSO3, then in this case, you will have CS3 and the CH carbon atom. Now this carbon atom acid OH and SO3Na. If you have something like this, a ketone plus NaHSO3, you'll have OH and SO3Na. All right, the fourth one, addition of sure. Grignard reagent. Now write in Grignard reagent. This Grignard reagent we have already done in alcohol, phenols, and ether. In the methods of preparation of alcohol, if you have Grignard reagent like this, C double bond O plus RMGX, the Grignard reagent is going to attack on the carbonyl carbon. The carbonyl carbon oxygen is going to get the pi bond. You will have O, and here you will have R. O will be attached with MgX. And when you add water, this oxygen atom will get OH. So you'll have carbon, the two bond as attached as it is, R group and OH. Okay, so there are three different types of reaction that you can have. If you have formaldehyde, formaldehyde has the two groups are hydrogen and hydrogen, double bond O. It is HCHO plus, let's suppose we have CS3MgBr. Okay, the first reaction, it will be in the presence of dry ether. Second, in the presence of water. So the two groups will be as it is, hydrogen and hydrogen. The double bond O will become OH, and this carbon atom is going to get CS3. If you have any other aldehyde, CS3, and this is hydrogen, double bond O plus CS3MgBr. In the presence of dry ether, second step is water. You'll have carbon, the CS3 as it is, the hydrogen as it is. This carbon atom will get a CS3 from the Grignard region. This CS3 is from Grignard region and OH. As you can see, formaldehyde gives 1 degree alcohol. All the other aldehyde is going to give you 2 degree alcohol. And if you have ketones, CS3 and CS3, double bond O plus CS3MgBr, it is going to give you 3 degree alcohol. carbon, the 2 CH3 as it is. Here you will have another CH3 and the double bond O will become OH. Please write these 3 reactions down.